Let's move to some rapid fire questions. What is the best example that you can come up with where real world evidence has been used to improve patient outcomes?
Well, I'm torn. I mean, the first thing I think of is safety registries, and like we learned about the metal on metal hips were dangerous. So those are huge medical device registries. And I think of the TAVR, the transaortic valve research, where we learned about different ways that valves could be successfully implanted beyond what it was first labeled. And that's led to labeling changes. And I think of disease registries like cystic fibrosis, which have been used to provide context for new meds. So I see tremendous promise in disease and condition registries as well as device registries for their follow-up and for their ability to rapidly augment information from the date of first market authorization.
Let me pick up a little bit on the medical device industry. We oftentimes don't delve into either the similarities or the differences in medical device versus biopharma. Is there anything different in medical device real world evidence research that you'd like to talk about?
Well, medical device research had a huge boost recently due to a very hard-fought, successful campaign to develop unique medical device identifiers.
Mm.
So you can't really study something if you don't know what it was. If I have a hearing aid, you need to know what the brand is. If I have a hip implant, you need to know exactly what each part was. So creating those uniform identifiers were the first unique identifiers, and the system for that was the first step. But then getting it into records was much harder because you had asked me before about what could EMR makers add. Every data element turns out to be hugely costly, and it's not, you need to get it in, make sure you record it correctly and store it, and I'm told it's very costly.
Mhm.
So you worry about the good development was being able to understand what the device was and to have long-term follow-up. But as you know, and many of your listeners might know, medical devices are approved often when in small changes to a predicate device, so an older device. And you take a complex thing like a hip, there are lots of predicate devices that go into it that necessarily haven't been that well studied. And the small change to something that you didn't really know how well the older thing worked is
Mhm.
hard. So it's really difficult. And because it's a device, it's difficult to study. The unique identifiers help, but also the medical device cycle is much more rapid than the drug cycle. So drugs get tweaked when its patents running out.
Right.
Uh, but medical devices, as soon as they get tweaked regularly. So, last year's device, even though it has the same name, may be different from this year's, or maybe it has a slightly different model number, but it's very, very complex. And we have developed a medical device surveillance system. I was privileged to be part of that planning committee. It's been a long time coming, but it's here, and it's what we need.
Mhm. Is it fair to say that medical device real world evidence research is messier than biopharmaceutical real world evidence because of that?
I would think so. I think you could go that far. I mean, when
Mhm.
we take a drug, we have a very thorough national drug dictionary that we all use, and we have an elegant, clearly defined coding system, and things don't change that much.
Mhm.
As we get into more personalized medicine, the drugs will be harder to study because, how did you do that CAR T therapy? I know you harvested the cells, and we followed a very prescribed method for doing what needs to be done to make an effective targeted treatment. But because it is so personalized, I wonder about the challenges of generalization from
Mhm.
small amounts of data. Not,
Mhm. Mhm.
but on the other hand, they're making huge impacts, so I don't want to slow them down.